So I think this is lecture 2 of friction, right? Lecture 2 or lecture 3, Siddharth?
So two.
No. So what we studied in the last lecture, let's take a recap. So we studied that the formula for the limiting friction was equals to mu s into n, where n is the normal reaction. The static friction can have any value from 0 up to the limiting friction. And the kinetic friction will have a formula mu k into n. We cannot compare static versus kinetic, but theoretically, we know that Fs max is greater than Fk. So again, we are not comparing the Fs, we are comparing the limiting value, which led to the relation that mu s is more than mu k. Now, this is as per the JEE syllabus, okay? Now, if we talk about the, modern day research, then it is found that between two Teflon surface, so between two Teflon surface, the mu s and mu k is found to be same. So this is just for general knowledge, but we will not consider this part in the theoretical discussion of friction as per the JEE preparation. So this is as a matter of fact. Okay. So this is just for your information. No need to even remember this part. Now, there are certain things that we have to take care while solving the numericals. So while solving numericals, and this is the key point that one should remember. So when you're solving the numericals, and if the coefficient of friction is given as mu, so if they do not mention the two distinct value, mu s and mu k respectively. So while solving numericals, if mu s and mu k are not mentioned separately, then take mu s and mu k both as equal. So generally even in JEE advanced or mains problem, generally they mention the mu s and mu k separately. But sometimes they do not mention. No need to worry if they are not mentioned. And from the context, it is clear that it is also not required. Take both of them as same value. Now, that is against the assumption, the theoretical assumption, but you are solving a numerical type problem. So there the theoretical assumption will not hold true. You take both as same. So we'll continue this assumption that mu s is more than mu k as and when required theoretically. So these kind of changes are well, some sort of, you can say, practical assumption which we keep in mind while we solve problems of friction. All right. Now we'll try to answer some simple question. And we have also experienced that friction is proportional to normal reaction. So any process by virtue of which we can affect the normal will also affect the frictional force value which may act on the body. So always keep in mind that friction is not a constant formula. It is a formula which is indirectly depending on the normal reaction. And therefore, how much friction will act will depend on how much normal you're trying to create. So if you are altering the normal, it will also get altered directly. I mean, of course, because of the relation itself. So you may increase or decrease the limiting friction as well as the kinetic friction by changing the normal. And you have to be careful that any action which is leading to the increase of normal will also increase the what? The frictional force. Okay. So imagine there is a block. Mass is m. If I'm applying no force and the friction coefficient is mu(s), and you can see I am putting the symbolic values of mu(s) and mu(k) as mu(s), mu(k) respectively. And the surface is indeed rough. And nothing is said about the force acting. In fact, there is no force acting on the block as of now, externally, except one force is acting, which is gravity, right? And gravity in turn will develop another force called normal reaction. So how much is the normal here acting on the block? The normal force acting on the
Sir,
block is how much?
mg.
Pardon?
mg.
Mg. Very. So normal is mg. Okay. So the normal is equals to mg, and any method by which you can change the normal will also change the value friction. Now the question is, someone is trying to pull this object. The block is pressed against the surface by gravity. When gravity is pulling down and surface is kind of stopping it. So someone is trying to pull the block or trying to move the block. The question is, what minimum horizontal force is required to move the block? And if we assume the block is in motion under that minimum force, then find its acceleration. So a very trivial problem, but indeed a logical one that we must solve. So what is first being asked to you, that find the minimum force that we must apply to move the block. So your first step should be to draw the ABD. So without delay, let's draw the ABD. So one force which is the external acting here, F. And as we discussed, the gravity will be pulling it downward. And as a result, a normal force will start acting on the surface. And because of the well-known tendency of the block will tend to move in which direction? Block means the bottom of the block. The surface of the block will tend to move towards the right. Hello, hello, hello.
Yes.
Yes, sir.
So what will be the direction of friction? Force
Left.
acting on the block. So I think this is obvious, right? I mean, there's no rocket science here. And this force, as of now, I don't know what is this. Let's call F. Now, as F will increase, F will also increase because it is static in the wheel. So how much minimum force you need to apply to in order to, move the block? When the block will start moving. So static friction is self-adjusting in value, but it can go up to some limiting value, right? Isn't it? So to move the block, F must exceed the upper limit of this friction, right?
Yes.
Because as long as F is less than Fs max, F will grow to the value and will stop it. So to set the block into motion, and then only to solve, you know the answer that F must be equal to Fs. What you will solve? You can just start like this. Okay. And what is Fs max? Tell me. So Fs max is having formula, right?
So US.
Mu-s? Only mu-s is the formula.
MUSM.
And what is n here? From the ABD, n is how much?
mg.
MG.
So you can substitute here, na, mu-s mg. And now the force should be technically slightly more than this to set into motion, but slightly more is as good as saying that just infinitesimally more. So numerically they are equal. Okay, so that's like a numerical answer will be mu-s mg. And the moment you apply slightly more than this force, the block will be set into motion. But once the block will be set into motion, what will happen? Once the block will be set into motion, what will happen? So what I'm saying is the block is set into motion now. Then norma will change or remain same? N will be same or different? Tell me.
Same.
And gravity?
Same.
And applied force?
Same.
So F is the minimum force which you applied. And the answer is this is mu-s mg. And now it is in motion. Because it is in motion, which friction will act on the body now? Will it be Fs or Fk?
FK.
fk.
So you can see that now force has suddenly decreased. And now we can add the Newton's second law, net force equals to. So for this case, we can say net force equals to mass into acceleration. So what is the net force? Tell me. So net force is how much?
mu-s mg minus fk equals ma.
So mu-s mg minus Fk equals to ma. What is the Fk now? What is Fk? What is the formula for Fk? Tell me.
So mu KM. Mu KMG.
What is N again? You can clearly see the A turns out to be mu-s minus mu k into g. And what is fascinating here, that acceleration does not depend on the mass. So acceleration does not depend on the mass. So no matter how heavy the block is, the acceleration is going to be constant. So under the application of force, the force which could have moved the body. So if with that force we set the body into motion, the friction will change the nature. So it will go from static to kinetic, and now it will accelerate because the friction force, the force which you apply to move the body is bigger than the force it will experience during the motion, as this is what we discussed in the last lecture. That it is always, difficult to start the motion than to continue the motion. And the logic was because to start the motion, we need to overcome the static friction, but to continue the motion, we need to overcome the kinetic friction. And because I'm still applying the force equivalent of the limiting friction, so during the motion, it will be bigger than the kinetic, and therefore the block will accelerate. Is this question clear to all of you?
Yes, sir.
Yes, sir.
Now, if the same question is asked in this way, with some numerical value, and friction questions are not solved similar to the log motion, here you have to do some checkpoints. Like first, you have to figure it out that what will happen by doing some calculation or by taking some cases. So I'll go back to the same question. And the force applied is horizontal force. It's a horizontal force. And the mu s is, let's say, 0.3. And mass is, let's say, 6 kg, because that doesn't matter anyway. Okay. So mass is 6 kg, and let's take g as 10 meter per second square to make it easy in terms of calculation. Okay, and now there are cases. So question is, find acceleration if F is 10 Newton, 12 Newton, 18 Newton. So find the acceleration for each case. And then you start solving the question. So you draw the ability, right? So the normal will act like this and so on. Or let me do it separately. So you complete the ability first, and you know how to draw the ability, right? And as when you start solving friction question in the very beginning, then just write F. Don't write FS of FK, because you don't know what we need to write actually. And this is mg and this is normal. So inherently that to move the block, we need to actually cross the static limiting friction. Okay, just Okay, so what you will do is you have to do something called checkpoint. You can't start solving question blindly. In fraction, you have to first do some checkpoint that you will check that how much money you have in your pocket. So it is like you are going for shopping, then you will not go and enter any showroom and expect that you will buy something, because if you have, let's say, 1,000 rupees in your pocket, you can't go to any automobile showroom to buy bike or car, or even you can't go to bicycle shop. So the idea is you have to check your money first, like how much you have. So because normal is well defined, so the thing is you should work with the normal first. So normal is well defined. What is the normal here? Mg. And because mass is given, everything is given. So what is normal here? Value wise, numerical value?
60.
So that's 60 Newton. Okay, so that's 60 Newton is the normal reaction. Okay, all right. So what is Fs max? This Fs max is like how much I can generate friction if required. So what is the maximum value I can generate? What is the limiting value I can have? And because normal is well defined, so this is also well defined. And you simply substitute the value. And you know that I can develop up to 18 Newton of force. 18 Newton is something I can prevent motion. If someone is trying to pull by 18 Newton or less, it will never start the motion at all. So A, B, C, D, A, B, C, all three forces are either less than or equal to 18 Newton. And the rule is simple. Even it is equal to 18 Newton, it will not start the motion unless someone gave a gentle push. So in all the three cases, the acceleration will be 0. I mean, you're not
0.
supposed to solve it. Yes, it is not going to, I mean, you're not supposed to solve it. It is 0. And now the last two cases is definitely more than friction, so it will accelerate, and therefore, because the force is going to accelerate, so it will skid over the surface, and the friction will be definitely kinetic friction for the D and E. So for D, you can simply say the ABD will be 21. And then you can keep one calculation separately. When time will come, then you can apply. So it is you can to N, which is 12 Newton, right? So you know the backward force is how much going to act? And so the acceleration will be how much? 21 minus 12 upon 6, right? Or you can directly write as mu s minus mu k into G, because this is what we derived earlier, right? So it is always the same answer. It doesn't matter. And what you can see that no, this is not the case, my bad, because we're not applying the minimum force. So this will be how much? 9 by 6.
1.5.
So the acceleration is going to be this much. The DE part you can simply solve. What is E part? So what will be the acceleration? Can you tell me the answer directly? A will be how much?
3.
Pardon?
3 meter per second.
So 30 minus 12, right? Net force is how much? 30 minus 12
By 6.
by 6, how much?
3 meter
18
per
by 6, which is 3 meters per second. So you can see the same question. I mean, you have to, if you want to solve question of friction, you have to do the checkpoint, keep some calculation handy, and then you have to compare things, then only you can answer it. So blindly, you cannot, jump to formula and, think of getting the answer. That's not the chapter is built actually. So that's why this chapter is kind of more thinking chapter. You have to think a lot actually. And you have to do all the checkpoints in every question. Every single question, you have to do this checkpoint. So we'll see some more questions differently. And hopefully we will try to develop the thinking process. Now, this is another very famous problem. And The problem is we have a rough surface. And the coefficient of friction is μs. A block is kept. Mass is m. And nothing is said about the force, the way it is acting. In the previous question, I said it is acting horizontally. Now I'm not saying how it is acting. The question is, find the minimum force required to move the block. Now it is, the entire game is on you. What you will do, how you will do, but you will do something to minimize the force. So it's a question of, you can say maximum, minima also. It's a question of trigonometry also. Question is what, and of course you have to move the block over the surface. So just to make this more clear. So minimum force, you are supposed to apply minimum force so that it can move and the force is minimum. It can move over the surface with a minimum effort. So what we will do and what we should do here. Tell me.
So μs mg.
No, that's the problem. Question is find the minimum force.
So μs.
No. What is μs? If mass is there, how μs can be the force? Huh? Μs is just a number. So first of all, to move the block, there must be some force acting parallel to the surface, right?
Yes. Sir.
And how you are going to minimize it? How to minimize the force? That's the question. So the idea is simple. If I apply force like this, then I have to actually apply a force μs mg to move the block, right? But if I apply force like this at some angle, theta, which I don't know, but if it is acting upward, then it will have two components. And look at this carefully. f cos theta and f sin theta. So do you realize something here? You are indirectly affecting the normal reaction. Do you realize this?
Yes, sir.
So definitely the friction will act this way. And because you want to move it, so this must be limiting only. So whenever the question is about find the minimum force or maximum force to move the block, or to maximum force which we can apply and block is still at rest, the language can be tilted either way. The meaning is same. When the friction is reaching the limiting value. And the limiting friction formula is μs into n. It is not mg, it is n. And what we have done here, by virtue of the application, if you're trying to pull upward, you're creating a component which is kind of lifting the block, and so it is decreasing the normal reaction. The pressing force will decrease, isn't it? So F sin theta will decrease the normal reaction between earth and the block, yes or no? Okay, anybody know what is the normal force here?
MG.
mg minus f sin theta.
Yes, sir.
Very good. So from ABT, the normal is actually mg minus f sin theta. It is no longer mg, right?
Yes, sir.
And to move the block, numerically we can say the f cos theta is the force responsible for motion, and this must overcome the mu s n. We can take more than or equals to, but we are taking the equality because we are trying to find the minimum force. So f cos theta is mu s n to n. But what is n itself here?
mg minus f sin theta.
And if you rearrange, you will get the f f equals to so f equals to mu s mg upon cos theta plus mu s sin theta. And what you can realize here, the f is depending on the theta. So we have to minimize the force. So we have to choose one particular theta which can give you the least value of answer. So for f to be minimum, the denominator must be.
Maximum.
See, remember here theta was not given to us. It is not that the force is applied at theta. We chose to theta as a variable, and we are trying to minimize. So there are two ways: either you differentiate and go through the differentiation process, which is not recommended. Other is use the concept from trigonometry, which we have already done the mathematical tools, and we know that any trigonometric expression of the form a sin theta plus b cos theta, the maximum value of this format is always how much?
Root a square plus b square.
So you can see the denominator is having the similar format. Do you realize this?
Yes, sir.
So what is the maximum of the denominator which you can write directly?
Root of 1 plus mu s square.
And because it is 1 plus something, so it is more than 1. The denominator is more than 1, isn't it? Right? The denominator is more than 1, yes or no?
Yes.
And because the denominator is more than 1, so this entire term is divided by a number more than 1. So the answer is going to be less than mu mg, right? So you can see the minimum force required to move the block is not mu s mg. It is less than that. It is mu s mg upon 1 plus mu s square. Do you realize this? Hello, hello.
Yes, sir.
Yes,
Yes,
sir.
And now this is the very standard problem. So this is like 5-star. You must remember the answer also, the process also. And it can come in J advance in some other format, but whenever there is a minimum or maximum force kind of question, and when the ABD is not drawn, nothing is given about there is no information about the force, you have to always pick some certain angle. And once you pick the angle, you get the right answer, isn't it? Okay. Also, if I take, let's take z equals to cos theta plus mu s sin theta. So for any function to be maximum, the dz by d variable, which is theta, must be 0. For z max, we know from calculus that the first derivative must be 0. And if you do so, you will get minus sin theta plus mu s cos theta is 0. So this will give you tan theta equals to so tan theta equals to mu. So it means the theta, which is equivalent of tan inverse mu s, will make the minimum force, will give you the minimum force. And if you draw the ABD, I'm sorry, if you draw a triangle, if you say this is theta, tan theta is mu s, which means opposite upon base is 1. So that's what this is. And now from here you can get cos theta equals to and sin theta equals to and if you substitute the cos from here and sin from here, you will get the same answer. If you want to do it by differentiation, so the F minimum you will get as and cos theta is 1 upon mu s into sin theta, which is and I hope you can realize this will turn out to be this answer, right? So once you simplify this, it will be similar to the answer above, right? Is this clear? Hello, hello, hello.
yes,
Is this clear, guys? Tell me yes or no.
Yes, sir.
All right. So I'll give you some very interesting way to solve this problem. And for that, you need to learn something more called the concept of so now this is again very important concept, inflection. So surface contact force. We know there are two types of force, In the very beginning of the laws of motion, we studied the contact and the non-contact one. And the contact force we further divide into two categories, the surface contact and the point contact. And the surface contact was further divided into two categories. Which two? How many types of surface we have? Surface contact force we have in general? Am I audible? Hello. Am I audible?
Yes, sir.
So how many types of surface contact we have?
Two, normal
Two.
and friction.
Normal and friction. Do you all remember this?
Yes, sir.
So why not sing? Okay. So let's say there's a block kept over a horizontal surface. So you can see the 2D view on the left and the 3D view on the right. It's a horizontal surface. And you may apply force on the surface on the block anywhere. So let's say you're trying to applying force on the right. So the tendency will be right, so friction will be left, and so on. Okay. So on a horizontal surface, in how many directions we can apply force? Infinite. So it could be any direction 360, right? And therefore, the frictional force developed can be anywhere. So it could be like this, like this, like this. It doesn't matter. So imagine the friction is left like this. Just imagine for some time. And this is static friction. So I'm assuming the block to be at rest, and someone is applying force to create that tendency. So block at rest. Just imagine block is at rest. So the friction will act horizontally anywhere. So I'm just showing you one of the direction, and the normal will act like this, right? Upward. So now this time I'm doing the normal like this. So normal and static friction both are part of what? Surface contact force, right?
Yes.
So what is the net force by the surface? What is the resultant force by the surface? So the resultant force by the surface is not upward or left. It is actually like this. So the ground is applying force on the block this way, not horizontal or vertical. Do you realize this?
Yes, sir.
This force is called the net force a surface can develop. This is called the surface contact force. R. Is this clear? Is this
Yes,
clear?
sir.
Yes or no? And since the normal is always vertical, but the Fs can have any direction in 360. Therefore, the R can also turn 360, isn't it? Do you realize this? What I have done now? So R can be the generatrix of this cone. So generatrix is like the if you rotate this R by keeping this angle constant 360, it will scratch a surface, it will traverse a surface, and that is the surface of the cone, right? Hello, hello, hello. Is this clear what I'm saying?
Yes, sir.
So the angle between the net surface contact force, which we actually represent by R, and the the normal, this is called lambda. This is called lambda. And this lambda is the called angle of cone, angle of friction, cone of friction, because it is creating cone kind of shape in which it can have angle with the normal. So this is various named, and R is the surface contact force. So normal and Fs are basically component of surface contact force. So N and F are component of surface contact force. So what is the magnitude of R in general? So R is always under root of N square plus F square. N square plus F square. So it is simply the square. You can square and add, you can get the answer. And how we can get the answer? It's a simple way of writing. You can say R cos lambda is actually we call N, and R sin lambda is something which we call F. I'm not writing Fs or Fk, it could be anything because depends on the situation. Right now in the diagram, since I have written block at rest, so I have written Fs, but it could be moving also. In that case, it will become Fs. Okay. And because these are the equations, so sometime if the lambda is given to you, they will never mention the coefficient of friction. Because if lambda is known to you, then you can find the Fs and N both in terms of R itself. But if they don't give the lambda, they give mu s or mu k. Okay. Is this clear?
Yes, sir.
And from here you can see that if I divide 2 by 1, it becomes tan lambda, and tan lambda is A by N. Okay. So now this is the formula, and now it depends. Like if we can replace by something in some situation. So if now we'll take some case. If F is equals to Fs max, then we know the formula is mu s into N. And in that case, the tan lambda becomes mu s, right? Which is very interesting. And the case 2 is what? If f equals to fk, then this will become mu k into n. And in that case, the tan lambda becomes mu k. So in a way, tan lambda is a known value whenever the limiting force is acting. Or in a way, you can say, given the lambda, we can find the given the lambda for a limiting case, we can find the mu s. Okay. So if the maximum contact, when the force is maximum, so force is maximum when the fs is max, right? Because
Yes, sir.
normal is always mg in this case. So fs can be maximum only when it is limiting friction, and therefore in the maximum, if the surface contact force is maximum, so in that case the tan lambda is always mu s. Once again, let me tell you, when the surface contact reaches the maximum value, the tan lambda becomes mu s, or you can say the lambda is tan inverse mu s, the way you want to say. So this tan lambda equals to mu s is very interesting because it always happens whenever there is a maximum surface contact force. So this is the case when surface contact force becomes maximum. So what is R max? So R max will be how much? Any guess? And because of the formula, we can say this is 1 plus mu s 4 square into n, right? So in this case, this will become 1 plus mu square mg, right? Hello, hello, hello.
Oh, yes, sir.
And what is the R minimum? So R is minimum when there is no friction. I mean, there is no tendency of motion, so it will be only n, correct? Hello, hello, hello.
Yes, sir.
So when there is no tendency of motion, the friction will vanish, but the normal will not vanish. In that case, the surface contact force itself is normal, which is mg. So the general value of R, and now this is very, very crucial relation. The general value of R in this case will lie from where to where? It can be from mg up to or in general, let's say if n is not mg, if n is something more, you can say it is going to be n to do you realize this? So this page is very important. You have to first understand this carefully, what I'm trying to say. If you have really understood, then only move on. Otherwise, try to realize this, what is happening here. If you have doubt, ask me the doubt. Then we will move to the next concept. And you can do some writing. So do make some writing, feel it. R is the single force which can replace N and Fs both together, or N and F both together. So when you draw R in the FBD, you're not supposed to draw N and F. Do you know this? You can't draw the R and N and Fs or F both. R means it will take care of the net surface contact. R is absent. If you're not trying to write R, then write the component N and Fs. Is this clear?
Yes, sir.
So it is like R will replace the two variable by a single variable, and it will take care of every force that surface possibly can apply. Okay. Does it make sense to you guys?
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Okay. So if you have realized, if you have written it down, then I'll show you something really interesting. So before that, we'll do some puzzle problem. So there is a very simple question. We have an inclined plane. We have an inclined plane. Sorry. So we have a rough inclined plane. So we have the rough inclined plane. And it is at rest. Now, if the surface contact force we represent by R, so in terms of surface contact force, how many forces are acting on the block? So it's like if we replace the normal and friction by R itself, then how many forces are left acting on the block?
So
You're not supposed to draw the, you're not supposed to draw the N and F separately. Then how many forces are acting on the block? Tell me. How many forces are acting on the block? Tell me.
so one.
How it is only one force? Which force?
So
Which force
there'll
you're
be
talking about?
there will be two forces,
Two force. One force is
mg and r.
mg and R. Very good. So mg is one force, and how mg acts? Vertically downward. The block is at rest under the action of two force. The other force must be acting in which direction, guys? Tell me. If two forces are acting on an object and it is at rest, then that both force must be
Opposite
Hello,
to
hello.
each other.
So both forces must be opposite to each other and equal in value.
Yes.
So how the R must be acting on this block? Can you guess? The
Sir,
R must be
upwards.
acting exactly upward like this. And we are not supposed to think much. And what this R is representing? It is representing the resultant of which two force?
Normal and FS.
Correct. So what is the angle made by this resultant with respect to its own normal?
Lambda.
No, no. You have to do it geometrically. There is no lambda here. I'm asking what is this angle? That's it.
Alpha.
Very good.
Yes, lambda.
It is alpha only. So here lambda is alpha, isn't it?
Yes, sir.
And therefore, pretty much you can say a lot of things. Now, if you want to ask what is friction force, what is F? F must be equal to what value?
mg sin theta.
What is F here? F is which component of R? F is always
Sir, R sin alpha.
R sin alpha. Very good. So R is the net force, no? So to find the friction, what will do? You will resolve R parallel to the plane, right?
Yes.
And what is R here? Because R is equal to mg, we have done this already. So from equilibrium condition, R equals to mg, correct? So now we got F equals to how much? Mg sin alpha. And that's why here friction coefficient is not required, because friction is actually balancing the mg sin theta only, right? Mg sin alpha. Even if you draw the normal ABT, you will get the same answer. And what is n value? What is normal?
R cos alpha.
And therefore,
mg cos alpha.
so let's draw the regular diagram and try to analyze the same thing. So if you do the regular diagram in which you introduce the normal and friction, so we know the tendency. What is the tendency of block? Up or down? Tell me, tendency is what?
Sir, down.
Down. How friction will act?
Upwards.
Up the plane. Make a habit of writing saying up the plane. So which friction will act? Static or kinetic?
Static.
Static.
Do we have any formula for the static friction? Yes or no? Do we have any formula for static friction? Yes or no? Tell me.
Mu SN.
There is no formula, no? We have discussed already. There is no formula for friction. Yes or no?
Yes.
See, mg mu s into n is the upper limit. The friction can develop up to that value. Does it mean it will develop that value?
No.
So you have a 2,000 rupee note in pocket and you go to the Pani Pure wala. So will you pay 2,000 or will you pay like what he will charge?
What he'll charge?
So do you know how much you need to pay here?
No.
And you know. So to keep the block at rest, what we need to do? How much the friction should be? To keep the block at rest, the net force must be 0.
Yes, sir.
And if you make the net force 0, it means the component wise it is also 0.
Yes, sir.
So component wise, N will balance what?
mg का sir.
And Fs will balance? So what we are doing is we are writing net force equals to 0. So if you want to, you can take X and Y. And you can add net force along X equals to 0 and net force along Y equals to 0. And then you can say Fs minus mg sine alpha equals to 0. This implies, or therefore Fs equals to m. Who does that? It's a visually you can see the answer. And then you will say, okay, I have to write like this, that n minus mg cos alpha equals to 0 because there is no acceleration in that direction. Therefore, n equals to. You may write like this. So depending upon your understanding which you have developed so far, if you want to write this way, you are free to write that way. So if something is at rest, then you can always make net force 0 along any direction, because if something is at rest, it is rest in all directions. And therefore, choose some suitable xy coordinate and write the net force equals to 0 to get the answer. And what could be more suitable than assuming x and y along the plane and perpendicular to the plane? So this is the general assumption that we make. So what do you see in the two method? Two different perspectives. Method one is something less seen. Okay, person, you can go now. Don't worry.
Yes, sir. Thank you.
So I think this idea is clear. How to approach the problem in two different ways. So when R will come, then what will not come?
Normal and fs.
And when normal and fs you are writing, then or f is writing, then don't write R. So what are the benefit of this? The first benefit is it reduces the number of variables. So many challenging problems can be solved by the R method in simpler way. Now that kind of question where you can expect, you won't expect anywhere except the first semester in the engineering mechanics. But apart from that, you can use that method to solve question faster. So we'll try to, see some application of this approach, and if we'll see that does it really makes life easier. So let's see. So we'll go back to the question which we have already solved. And the question was, find minimum force required to move the block over the surface. Okay. And now I have no idea. I have no idea what will happen. So one thing I know that if I'm trying to apply for something like this at somewhere here, the R vector, let me first draw the force, and you draw all forces, the normal, mg, friction, normal, mg. And because we're trying to move the block, so we have to overcome the limiting friction, right? So I'm going to add fsn, fs max. Okay. I don't know how f is active, but I know one thing. To make diagram simpler, I'll replace the block with a dot sign. It is also easy for you. And then you can see the force acting is R is like this. And because it's because Fs is maximum, so R is also going to be maximum. So this is basically R max. Do you realize this? Because when F is maximum, the R becomes maximum. Yes or no? Maybe not. Huh? Don't realize this. So this will be how much? This angle. Can we find this angle? Hopefully, don't remember. This angle in that case will be tan theta equals to mu, right? Mu s.
Yes.
How? Because this is mu s n. This is n. And so tan theta is mu s n upon n, which is mu s, right? So tan theta is mu s. That is what we know. Okay. And mg is downward. We know this. All right. And now we have to figure it out that so which force is bigger? Clearly you can see mg is going to be bigger, right?
Yes.
Or R max is bigger. Which one is bigger here? R max was mg into 1 plus mu square, right? N into under root of 1 plus mu square, right? So R max is bigger here. So anyway, you can see there are two forces. One is R max and other is mg. Now what you need to realize that no matter how you're going to apply the force, the R max will have fixed direction, isn't it?
Yes.
Because
Sir.
R max, see, as normal will change, the Fs max will change, but the ratio will be always fixed, which is only depending on the mu s. So what is interesting to note here that the R max will never change. And now we are supposed to find the F value, which is minimum. And for that, we do something interesting. So what we do is, this is R max, which you know the angle. I mean, I'll just do the angle. and we know this is theta. And we do have mg also. So what I'm trying to do is mg will be like this. This is mg. This is r max. What else? So that if these are two vectors, the r max mg are two vectors, so the force is nothing but the third vector closing this triangle. That's the whole idea. And you want to minimize this, right? You're looking for the minimum value of f. How we can minimize this? Any guess? What is the minimum distance between two lines? I mean, not two lines, or point and line. So from here, I want to draw a line which is of minimum length. So if I extend this line, if I make mg bigger, there are problems. So if I make mg bigger, it will be like the line will become even bigger. If I make the mg is smaller than this line is something like this. If I take mg up to here. So how to make mg so that it is minimum? So what is the minimum
It has to be
distance?
perpendicular.
It has to be perpendicular. And therefore comes the idea. The minimum force is only possible when the f vector is actually perpendicular to the r vector. It means I must draw the f vector which is exactly right angle to the which vector?
R
R
max.
max. This must be 90. And this is what we have to realize, that it is going to give you the answer only when the f is going to be at a right angle. And then you can realize directly that this angle becomes theta also, right? So for f minimum, f and r max must be perpendicular. Do you realize this? This must be perpendicular, which means this angle must be 90. And if this is 90, then everything is sorted because this is theta. We know because this is theta, right? Mg and normal are parallel. And this vector wise, you can think this is mg actually. So if it is a right angle triangle, then what is f from the triangle itself? How much is f? In terms of mg, can we write f equals to how much? If it is a right angle, can you tell me what is f minimum?
Sir, mg by sin theta.
Why mg by sin theta? Why not mg sin theta?
Yes, sir, mg sin theta.
This is perpendicular. Now for this angle, this is perpendicular, right? And mg will act as hypotenuse because it's the biggest side. Isn't
Yes,
it?
sir.
And therefore, the answer is simple. If you can draw this triangle, and if you can realize that this is a triangle which I have to draw, the f is actually equals to, and we are done. Why we are done? Because the theta which I have used here is tan theta is mu s, which is mu s by 1. So it's opposite base. And do you know what is sin theta? It is mu upon, which simply means the F minimum will be mg into what we got here. With practice, you can master this. So if whenever there is a R max, it is always tan theta equals to mu without any default, without any doubt actually. And whenever it is right angle triangle, because the three force will make a right angle triangle, so it is easy to do the component or writing the sine theta or cos theta easily and get the answer. It is clear. So interesting thing is that the direction of R max is fixed, and we have to draw the mg in such a way to make the F minimum, which is only possible when it is perpendicular, right? So this is the fixed line. This line is fixed line. Mg is also fixed line. And F we have to decide in a way to make it minimum, and that minimum is only possible when it is right angle. So this idea of drawing the R max direction and mg, and because mg is a known quantity, so we have to express the answer in terms of mg directly, so we can get the answer directly. It is clear?
Yes, sir.
Does it make sense to you?
Yes.
So the minimum force required is this much, mg sine theta, where theta is this much, and you can get the answer. Okay. Next part. So try practicing it. You have another class now? Why?
Yes, sir. It is that teacher does not have schedule. She takes मतलब अचानक से वो बोलती है कि कल क्लास होगा.
But you know now this is your timing. So is it which class? Your private tuition or the school like
No,
coaching?
private.
So you must be knowing your lecture, no? Lecture time. So you can communicate. So you have lecture. If you're missing the lecture, if you do you watch the lecture?
Yes.
So your other side don't have the online lecture?
No,
it
it is
offline?
offline.
Offline. Okay.
Hmm.
All right. You can go.
Okay, sir. Sorry.
We will see some more application as we attempt the more difficult situation. So similar to the same question, there is another question. And now we have block over the inclined plane, rough inclined plane. Okay. And oh, this is not right. Only thing given to you is this is mu-s, which means it's a rough surface. And the same question. Find the minimum force required to move the block. So same question. So definitely to move the block, the R max will be acting at what angle? Will you try this question? Siddhant, you want to try this?
Yes, sir.
Okay, you try this and I'll solve it. Okay. Okay, done, Siddhant? So it is a similar process. Either you can do by the similar method which we have done for the very first method, like component, or you can do by the vector. So the R max is always like this, right? So R max will be at angle theta, such that the tan theta must be equals to mu, right?
Yes, sir.
And
So
mg
in this
will act
case, the
like this.
block is moving upwards.
No, it's still at rest. No, you're supposed to move the block up the plane. Yeah,
Oh, I
yeah. I
don't-
have to mention this. The minimum force got to move the block up the plane. And mg is acting like this, right? So earlier the diagram and this diagram is having slight change, but still the method remains the same. So this is the R max, and this angle, if you remember, this angle. So if you draw a perpendicular, I mean, okay, I have to make it image. Yeah. So this angle was how much, if you remember? This is always alpha, right?
Yes, sir.
And the only difference is with respect to vertical, the angle will change from theta to theta plus alpha. That's the only difference. The rest is same. And mg will be like this in such a way that, okay, I will draw first a perpendicular. No, I'll draw perpendicular first before I. And now the mg, which I should do like this, it will be something like this. So it's the same diagram with same 90. This is your F minimum. And this will be theta plus alpha. This is mg because of the diagram. And the answer is clear. What is F minimum? You can see. So to write this is R max. So F minimum will be how much? From a triangle this time. Tell me what is F minimum? It is mg sine theta plus alpha. That's it.
Yes, sir.
And you can actually expand it, which is sine A cos B plus cos A. And sine, because here what is tan theta? So if you remember the sin theta is, okay, can I directly now? I hope you should understand this. So, mg sin theta is minus cos alpha plus upon 1 plus minus square. So this is the answer. Okay.
Yes, sir.
All right. So not very difficult, but by this method it is pretty easy. Or you can do the similar method which you did, take component, solve it. So Okay, let's do the next problem. So now we'll go back to the easy problem. So let's say we have an inclined plane of angle theta, and there is a block. And now I'm applying a force. Coefficient of friction is mu s. Find range of F. I think I should just teach you something interesting. Okay, so now we are going to discuss the next big concept, and that is called the angle of repose. So you can name it by any value, theta or maybe lambda also. So what is angle of repose? So it is called, it is the angle at which, it is the angle of the inclined plane over which if you keep any object, then it will move if the angle will exceed this angle, and it will remain at rest if the angle is equals to or less than this angle. So we can say this is the angle at which the motion is impending. It is about to happen. So how this is actually done? So you can take any horizontal surface. So imagine you have a cardboard in your hand, a big cardboard. You can think of whatever you have right now. Just hold it. You have any cardboard?
Yes, I have my book.
Okay, take the book. Do you have eraser
Yes.
or any sharpener, eraser, whatever you have? Just put the eraser on your notebook. Keep the notebook flat, horizontal. Okay. Now slowly raise the one side of the book, keeping the other side fixed so that it should form an inclined plane. So when you tilt a bit, do you see is the razor moving downward?
No, sir.
So tilt a bit, slowly keep on increasing, slowly. And you can see the razor is still not moving, but after some angle it will move.
Yes, sir.
It moved eventually, right?
Yes, I moved.
So the idea is the angle at which the motion is started or is going to start, or that angle we call angle of repose. It means if something is below that angle, no matter what is object, it will never move. And the coefficient of friction, will predetermine that motion. It is nothing to do with the mass of the object. So whether we have an elephant or whether we have a mouse, if they are wearing the shoe of the same company with similar feature, standing on the same plane, both will start skidding only at the same angle. So mass doesn't decide the repose angle. That's very interesting. So what is the angle of repose? It is the angle plane at which motion of bodies kept will be independent it is always independent of mass of object and depends upon the nature of pair of surfaces in contact. So if you are standing on the surface, if someone else is standing, if you're wearing the shoe of different brands, so probably you will have different angle of repose because they will have different surface, different quality. And so the different angle of repose as well. So how we find the angle of repose? So it is the angle at which the friction reaches the limiting value. So you can also write like this mathematically. At this angle, friction, you can say static friction, it reaches its limiting value, which means Fs is always equal to Fs max whenever there is the angle of repose. So that is the beauty, like whenever there is angle of repose, it will always become limiting friction. Okay. So you can draw the APD and you can again realize that how the friction will act. It will always act parallel to surface, and because the tendency is to go down, so Fs max will be mu s n. And what is n here?
mg.
N is, what is n?
Oh yes, mg cos theta.
So when theta is theta r, then n is mg cos theta, and you can just start the for equilibrium. For equilibrium. Mu s mg cos theta is equals to mg sin theta, and then you can see the mg gets cancelled. What you're getting is tan theta equals to. And this is very interesting phenomenon, that the angle of repose is same as the mu s. And of course, because the block is at rest, then we know that the r will be exactly upward, right?
Yes.
Isn't it? So we know the tan, and that because this angle is same angle as this, so this is tan theta equals to mu s, because the angle of cone will be also in this case same as this angle, right? So,
Yes, sir.
okay, this is like this exactly. This is also theta only because of the similarity in a situation like this. And because we know this angle of cone for the R max is always mu s, so angle of cone is also, so I can say in this case, the lambda and the mu s will be, sorry. So here the tan of lambda is same as tan of theta is same as mu s. So basically you can say mu s is same as theta. All are same actually. Now what you are supposed to remember, that you are only supposed to remember that tan theta of repose angle is equals to mu s value. Tan of angle of repose is mu s. Okay. So when tan of theta is more than mu s, what will happen? Will it move or remain at rest?
Sir, move.
So this is a very direct general criteria that for any block to move over inclined surface, the only condition is that the angle of inclination of the plane should exceed the mu s value. The tan of angle of inclination of the plane should exceed the mu s value, then only it can move. Otherwise, it will never move. Okay. So we can add the condition criteria for motion. And it's very interesting. If the coefficient of static friction is exceeding the tan of angle of inclination, it means if the friction dominates, it is like mu s is bigger means friction dominates. The block will remain at rest, it will never move. So it is not only more than, even it is equal. In both cases, it will not move. For block to move down the plane, we must check the mu s must be less than tan alpha, where alpha is angle of inclination. So again, every question which you solve on the inclined plane, alpha is the checkpoint. You have to check first these values. You have to actually compare mathematically because they will give you numerical values. Even in JEE Advanced, they clearly mention the values. And the values, they will be give you very weird values, very fractional kind of value. But no need to worry. You have to just compare. And you have to just realize that, okay, this is more or less. And once it is at, I mean, if the tan of alpha is less than the mu s value given, then you should know that it will never move. And therefore, no need to, solve the question further. It's just like, okay, we know it will never move. That's it. So in friction, you can see there is always some sort of checkpoint. And that checkpoint will let you know that whether something will move or not. And the angle of repose is having very fantastic application in our day-to-day life, which we don't realize much. So you might have seen that, in kitchen generally, when you pour some powdered form of, grain, let's say either rice flour or maybe wheat flour, if you start pouring from the bag, it forms a conical heap. Have you seen that?
Yes, sir.
And why this conical heap is formed? This is very interesting answer. Even between the grains, there is a friction. So whenever you start pouring, if the slope exceeds the repose angle, the grain starts coming down. Okay. And they will always keep on coming down till the heap, the slope of the cone, the slant. If the slant is like a inclined plane, and if that inclination is less than the repose angle, it will be stable. The moment it crosses, it will start falling to the next layer. So it will change the slope actually, because you're pouring some material actually. So that's very interesting that every heap formation in nature, whenever you pour anything, if you pour salt, any powder form, even a bigger object. So let's say you start pouring the pebbles. Or not only that, I mean, if you have the loose, anything loose, let's say sand or soil, if you start pouring, it is always the conical heap. And this conical heap is because of the friction force actually. So it is a friction which is stopping the, the fine grain to fall further. Okay. And that is always there. So this angle of repose is a very interesting idea, and we do use this idea for a variety of situations. I'll show you one example. So the idea is simple. You start pouring something, and something starts taking the shape of a cone. It's a roughly a cone. We are just approximating like it's a cone for mathematical simplicity. Okay. And so this is what you have poured actually. And you have poured certain amount actually. So this is H, let's say this is the R of the radius of the cone. Let's call it smaller, not to get confused. So what will happen that if you have poured a V volume of something, then V we can write as V equals to. So what is the formula for the volume of a cone? 1/3 of pi R square H,
R
right?
square H. Yes.
And if the grain will have the coefficient of friction, static friction mu s, then they will stop at angle which is exactly equal to the repose angle. So the moment this is a repose, it will stop. It will not fall further. It will maintain this cone shape, assuming you're pouring really slow. Okay, I mean, those things are taken into consideration for the assumption. So what is happening? The tan theta, because it is a repose angle, we can directly replace by mu s. And we know from geometry that tan theta we can write as h by r. So there is a direct relation between the height of the cone and the radius of the base actually. And that's very interesting. It is mu r. So as the mu s will increase, the h will grow actually. So for a smaller base, you can have a bigger cone. Generally, if the friction is very small, you can see the heap is really flat. I mean, very small slope. And now we can actually convert the H and R in terms of volume, like how much you have poured will give you all the answer. So if I call the question 1 and if I call the question 2, I can just solve the question 1 and 2 to get R and H both in terms of V actually, because V is fixed. Okay, so this is like a something. We have poured something. Okay. And remember that we are just taking a perfect conical shape for the sake of writing. Okay. So let's substitute the value from 1 to the V equals to 1/3 pi R square. H is how much? Mu s into R, right? Writing same symbol. So R cube is how much? So R is how much? So H is how much? So we can exactly find the dimension of that cone given the volume. But there is a more interesting thing that given the height and R, because we can apply the geometry to find the height of the heap and R of the heap, we can actually find the mu, the coefficient of friction. So you can go in your kitchen and you can start pouring the salt slowly, and then take the measuring tape, find the diameter, and find the height, and then you know what is the coefficient of friction between the sand particles. I mean, sorry, salt particles. So that's a very interesting experiment you can do to find the mu(s). And then you can actually guess that if I pour this much amount of salt, you can calculate the height and then match with the formula. And that will be really interesting, fun actually, if you can perform things like that. Okay, up to you. So this is really interesting question in which we can use the idea of repose in a variety of ways. So these are the major concept in friction. Beyond that, there is no concept, but we have to only solve numericals to get some more insight into solving. So we'll do some problem practice only. Theory we have done. So let's start doing the simple problems from laws of motion. So we have M, and now I'm applying a force like this. I'm not saying it is not given. This theta is given to you. So now theta is given to you. So how I'm applying the force is known to you. And coefficient of friction is mu. So mu is now mu(s) and mu(k) both are mu only. No need to take. And what is said in the question that if block is moving with constant velocity, then find the value of friction force. I think in that case, even mu is not required, but they may ask you find the value of friction force. Can you find the value of friction force? Let's say now I think mu is not required. If only this is given to you. What will be the value of friction force? So this block is moving with constant velocity. So what is the acceleration of the block?
0.
Okay, so now I hope you can do this. So what is the value of friction force?
So F cos theta.
Correct. It is F cos theta. Because to have no acceleration, net force is balanced. So the horizontal forces are only F cos theta and friction, which is kinetic friction in this case. So F is here. F cos theta. Okay. And can you find mu? Because you know F, you can find mu, right? Of course, this mu is same as mu, okay? Or you can say find mu k. That's also fine.